Good day everyone! Welcome to Project M Squared. I am Sir JC, your guide in making math easy. For today's video lesson, we will solve word problems involving permutations, which require condition. This video is guided by the most essential learning competencies as solves problems involving permutations. Let us start with the most common problems involving permutation, that is arranging objects or persons in a row. Number 1. In how many ways can 8 individuals be seated in a row of 8 chairs if 2 individuals wanted to be seated beside each other? Given that there are 8 individuals to sit in a row of 8 chairs, we know that there are 8 factorial ways for them to be seated in any chair they want. But we have a condition to satisfy. That is, 2 of them want to be seated side by side. To illustrate, I have here cut out pictures to easily show the scenario. Let these 2 individuals be the person who want to be seated side by side. Since they want to be seated side by side, it is easier to illustrate if we represent these 2 individuals as a group or as one. By illustration, we have 8 individuals or range, where 2 of them are counted as one. By manipulation, it seems that we are just arranging 7 persons. To determine the total number of possible ways for these 8 persons to be arranged in a row of 8 chairs, where 2 of them are seated side by side or beside each other, we will use fundamental counting principle. By fundamental counting principle, we are going to determine the number of possible outcomes for each event. In this way, we are identifying the number of possible scenarios that each chair can be occupied by these individuals. The first chair can have 7 possible outcomes. Counting these 2 individuals as 1, 2, 3, 4, 5, 6, 7. So for the first chair, we have 7 possible outcomes. Suppose the first chair has been occupied. For the second chair, we now only have 6 possible outcomes. By counting 1, 2, 3, 4, 5, 6. Suppose the second chair has been occupied. The third chair has now 5 possible outcomes. Again, by counting these 2 individuals as 1, 1, 2, 3, 4, 5. Suppose the third chair again has been occupied. So the fourth chair has only 4 possible outcomes remaining. 1, 2, 3, 4. And suppose the fourth chair has been occupied, this pattern will continue until the last chair has been occupied. Now, we know that these 2 individuals who want to be seated side by side can interchange their positions so that they are still sitting beside each other. And this can be done in 2 factorial ways. So to include these positions, we need to multiply the product 7, 6, 5, 4, 3, 2, and 1 by 2 or 2 factorial. And this is illustrated as the solution to our problem using fundamental counting principle. So our answer will be the product of 7, 6, 5, 4, 3, 2, 1, and 2. Remember, this 2 is the value of 2 factorial, which represents the number of ways for those two persons who want to sit beside each other. So, our answer is 10,080. There are 10,080 ways for 8 persons to be arranged in a row where 2 of them want to be seated beside each other. We can also answer the problem using the formula for permutation. By observation, the product of 7, 6, 5, 4, 3, 2, and 1 represents permutation of 7 taken 7. While the value of 2 has the same value as 2 factorial, or permutation of 2 taken 2. Since we counted the 2 individuals who wanted to be seated beside each other, it seems that we are just arranging 7 individuals in a row, and this can be done in permutation of 7 taken 7. Furthermore, 2 individuals who are seated side by side can interchange their positions while still satisfying the condition that they are seated beside each other, and this can be done in permutation of 2 taken 2, or 2 factorial ways. Therefore, by permutation, the solution will be in form of permutation of 7 taken 7 multiplied by permutation of 2 taken 2, which is the same as 10,080. Number 2. In how many ways can 6 persons be seated in a round table with 6 chairs if, letter A, 2 individuals wanted to be seated beside each other? Letter B, 2 individuals do not want to be seated beside each other. By definition of circular permutation, we know that there are n-1 factorial ways for n objects or persons to be arranged in circular manner. So if there are 6 persons to be seated around a circular table, there are 6 minus 1 factorial ways to arrange them. But again, there is a condition that 2 individuals wanted to be seated beside each other. In this case, these 2 individuals who want to be seated side by side will be counted again as 1. So instead of letting n as 6, we let n be equal to 5. The 2 individuals who wanted to be seated side by side can interchange their positions but still seated beside each other. This can be done in 2 factorial ways. So the solution will be quantity of 5 minus 1 factorial multiplied by 2 factorial. 5 minus 1 factorial is 4 factorial. That is to be multiplied by 2 factorial, which we know, which has the value of 2. So the solution becomes 4 times 3 times 2 times 1 multiplied by 2 times 1. By multiplying all the factors, 4 times 3 is equal to 12 times 2 is 24, times 1 is 24, times 2 is 48, times 1 is 48. Therefore, there are 48 ways for 6 persons to be arranged around circular table wherein 2 of them are seated beside each other. Let us now proceed to the next condition of this given problem. And that is, 2 individuals do not want to sit beside each other. To answer this problem correctly, we must determine the total number of ways for these 6 persons to be seated around circular table without conditions. Furthermore, we will use our answer in the previous condition. Remember, by definition of circular permutation, there are a total of 6 minus 1 factorial ways for 6 persons to be arranged and seated around circular table. This 6 minus 1 factorial is evaluated as 5 factorial, which has the value of 120. This means there are 120 ways for these 6 persons to be seated around circular table. Of these 120 ways, the number of ways for 2 individuals are seated beside each other and the number of ways for these 2 are not seated beside each other or included in this total number of ways. By rule of complementary events, the number of ways of sitting beside each other plus the number of ways of not sitting beside each other should be equal to the total number of ways. In symbol, that is n of a plus n of a prime must be equal to the total number of ways, or n of t. So if we let a be the event of these 2 individuals are seated beside each other, then the complement of a, which will be written as a prime, will be the event of these 2 individuals not seated beside each other. Remember, the total number of ways for 6 persons to be arranged and to be seated around circular table is equal to 120. This represents the value of n of t. We will use this equation enable for us to solve for the number of ways for 2 individuals not to be seated beside each other. By substitution, n of a is equal to 48. This 48 is the number of ways for 2 individuals to be seated beside each other. This is our answer in the previous condition. Added by n of a prime, which is what is asked, substitute n of t, which is equal to 120. Using property of equality to manipulate the equation, we can cancel out 48 by adding the additive inverse of 48 to both sides of the equation. So, what will remain at the left side of the equation is n of a prime. So, 120 plus negative 48, that is equal to 72. And this 72 represents the number of ways for those two individuals not to be seated beside each other. That ends our video lesson for this day. I hope you learned something from this video. Again, this is Sir JC reminding you, math is easy when you perceive it positively.